Okay, so let's discuss the circuit for part A. Um, we have our transformer. It's not connected yet because we don't want to connect this yet. The output of the transformer, that's 12 volt AC RMS, that is connected to my power strip. This plus minus. This is phase and this is neutral. This is no longer a plus or minus in here. It says on the manual, but that's not how AC systems work. There's a phase and there's a neutral. What we are trying to do here is connect this DF005M, which is this whole thing. It's a DF005M. That's a bridge rectifier, and it comes like this. This guy, it looks like an op amp, but it has only 4 leads. Okay, this guy hiding in the middle. It has 4 pins, which we have already discussed through a picture. This is one of its AC terminals. That's the phase, that's the neutral, and this is the ground. The ground which you're looking at here right now, that's the ground. That is this terminal right here. The top right terminal is the ground, and the bottom right terminal is the plus. This guy, that's plus, that's ground. Okay, or here it's minus. So the rest of the components are capacitor, which is a 1000 microfarad capacitor, and the resistor is a 500 ohm, 1 watt. It's a power resistor. So that's my 500 ohm, 1 watt power resistor, and that's creepy looking capacitor. It looks like a worm, which makes your hands stink if you touch it. That capacitor is connected just the way it says. One end goes to the plus of the bridge rectifier and the other end is grounded. So the plus end, which is this side, the darker side, this goes to the plus of the bridge rectifier right here, and the minus side is grounded on the other side. Again, this ground is not the same as the minus of the AC. AC has a phase and a neutral. There is no ground on the AC side. On the DC side, there is a plus and the minus, and minus we can treat it as a ground, right? Like right here. So here, going back, the plus side of the capacitor is connected to the plus of the bridge rectifier right here, and for the resistor it doesn't matter, but it should be in parallel with the capacitor. So this, again, another lead coming out of this bridge rectifier plus goes to the resistor. Both of these elements are grounded together on this side, and again, this ground is different from the neutral. Like here, I have not connected anything across. So that completes my circuit. Where's the output? So what we have to measure this DC component of V output and peak-to-peak ripple measurement. So the plus of the bridge rectifier is basically my output, and I have my multimeter leads connected in here. That's why it looks a little bit crowded. What I also have is oscilloscope lead connected. So you see the purple cable coming out, that is my oscilloscope lead. The oscilloscope lead ground comes here. There's a lead coming out here just for convenience. I have connected it, and this is my multimeter lead, and you can tell because of the insulation which you see here. There's no insulation on the oscilloscope lead here. I didn't use it because I didn't think it's necessary. It's pretty far away from what I'm doing right now, so it's isolated. So with that, we need to see what the output looks like.